Hi everyone, Radko Tutor here explaining. In this video, we are going to look at how to find the kernel of a linear transformation. So what is this kernel of a linear transformation? So we are going to start by defining a kernel. So we are saying we are getting what we call as the kernel of a linear transformation, All right, so what is this kernel of a linear transformation? So a kernel of a linear transformation is defined as the set of all zeros. So a kernel is defined as a set of all zeros. So in other words, kernel defined a linear transformation as a set of all zeros. That means that if you are given anything, let's say you are given some equations or you are given some matrices, he said that those equations or matrices must be equated to zeros. In other words, they must consist of zeros. Okay, so that is what Kernel talked about. So in other words, if you have a function f of x, that function must be equated to 0. That's what we call as the kernel of a linear transformation. All right, so how then do we find the kernel of a linear transformation? So we are going to have an example so that we can find this kernel of a linear transformation. All right, so this is our question that we have here. The question is saying find the kernel of a linear transformation. So find the kernel of a linear transformation defined by w of x, y, s, and t is equal to, so we are given these equations here. So we are given how many equations? We are given 1, 2, 3 equations. All right, now if you are given such a question, whenever you are given some equations and then they'll ask you to get the kernel, what you must know is that a kernel is just putting those equations in an augmented matrix. So if you put these equations given in an augmented matrix, then you are getting what we are calling as the kernel. So let's do that. So you put these equations, there are 3 of them, put them in an augmented matrix and then solve for the missing variables. So in this case, we are solving for x, we are solving for y, we are solving for s, and we are solving for t. So after you get the values of x, y, s, and t, that means that you've gotten the kernel. So let's do that. So by doing that, we are going to say that we have our augmented matrix. So solutions are here. So solutions, we are going to get these equations here and put them in an augmented matrix. So in augmented matrix, we are going to have the 1. Remember, the first equation is having 1, -1, 1, 1. We are getting the coefficients only. So 1, -1, 1, 1. And then the other one is we are getting x is 1. So we put 1 here. Then we don't have y. You've seen in the next equation there is no y. Y is missing. So meaning that we are going to replace y as 0. And then we go to s, which is 2. So we put 2 here. Then from there is minus, that is a plus t. Oh, let me check. That is minus t here. So let me just write it again here. Minus t. This is a minus here. So minus t, meaning that we put what there? Negative t here, or -1. Then we go to the other equation, you are getting the coefficients. So you get 1, 1, 3, -3. So that's what we are going to do. So 1, 1, 3, -3. So remember, what are we getting? We are getting what we are calling as the kernel of a linear transformation. So how do we get the kernel? To get the kernel, simply equate these to zeros like that. So after equating them to zeros, what you're supposed to do is to find or to get the missing variables. So for you to get the missing variables, what we are simply going to do is to solve these systems of equations using Gauss-Jordan or Gaussian elimination. So by using Gauss-Jordan, we know that we are supposed to make this number as our reading entry, and then these two here must be made zeros. Remember, a reading entry in a row must be the only non-zero in that column, meaning that the rest of the numbers, this and this, must be zeros. So we are going to make them zeros. How can we make them zeros? We are going to say that we are in row 1, or that is row 2 rather, is equal to row 2 minus row 1. So for you to make this number here a 0, just simply subtract this minus that. Also making this a 0, also the same, you subtract this minus that. So that's what we're going to do. So we say we are also in row 3. The formula is row 3 minus row 1. So by doing so, we are going to have to keep the first one constant, which is 1, negative 1, 1, 1, and then 0. Then we subtract row 1 minus 1. So we are saying this minus that, which is a 0. 0 minus negative 1. So 0 minus negative 1 is a 1. 2 minus 1, that is a 1. Negative 1 minus 1, we get a negative 2. And then we put a 0 here. Then from here, we also go to the next one. We have 1 minus 1, which is a 0. 1 minus negative 1, we are going to get a 0 as well. 1 minus negative 1, are we getting a 0 there? Let me just do it. Now we're getting a 2. And then 3 minus 1, when we say 3, this 3 here minus 1, we are getting a 2. So we write a 2 there. And then negative 3 minus 1, negative 3 minus 1, that is going to give us negative 4. And then this is a 0. All right, so that is what we have in the first place. Now remember, we should also go to the next row and make this as our reading entry. So this is our reading entry, meaning that if this is our reading entry, it means we should make this number here a 0, this number also a 0. So by doing so, we are going to say that we are in row 1. For us to make this number here a 0, we just add row 1 plus row 2. So by doing so, we are going to say row 1 plus row 2. Then for us to make this one here a 0, we are going to say that we are in row 3. The formula is row 3 minus 2 row 1. So you just need to put 2 to row row 2. So we just need to put 2 to row 2 in order for you to make this 2 here a 0. So by doing so, we are going to now write our matrix. So our matrix, we are going to maintain, which one are we maintaining? We are maintaining row 2, which is 0, 1, 1, 2. 2 there, which is a negative, and then we put a 0 like that. So remember, we are saying that we are getting the numbers in row 1 by using this formula here, where we are just adding row 1 to row 2. So row 1 plus row 2, which is 1 plus 0, we are going to get a 1. Negative 1 plus 1, which is a 0, of which we wanted to get. 1 plus 1, we get a 2 here. And then we have 1 plus negative 2. We are going to get negative 1 and then 0 there. So for the last one, we are using this formula, which is row 3 is a 0. Minus 2 row 2, we get a 0 there. For this one, we are in for this number here, we are going to say row 3 is a 2 minus 2 row 2 is 1, which is going to give us a 0. So we get a 0 here. Here in this number also we shall get a 0 because we have simply same numbers here, so we get 0 as well. Then here we say we are in row 3, which is negative 4 minus 2 row 2, we get a negative 2. So we put negative 2 here. And therefore we shall have negative 4 plus 4, which is also giving us a 0. So we get a 0 there and then a 0 there. So you've seen that the last row of this matrix is giving us row of zeros, and then this matrix has already been made to reduce to echelon form, which is also called the Gauss-Jordan. So in this case, this number in this row is the reading entry, which is a 1, and it is only non-zero in that column, correct? We come to the second row, this is the reading entry, and it's only non-zero in that column, meaning that correct, and the row of zeros is placed down the matrix. That means we are done reducing. So after you are done reducing, what do you do for you to get the values of x, y, s, and t? You just need to correct what you are remaining with now. So to correct what we are remaining with, you have the first row, which is x plus 2y. Oh, sorry, that is, so remember the first number is represented by x. Let me just write this for you. The first number here is x, this is y, this is s, and that is t. So you are going to say the first number is the x, the y is a 0, so you go to plus 2s. So you say plus 2s minus t. So minus this t here, and then is equal to 0. So you equate that to 0. So from here we go to the next equation, or the next row. We have the y plus s minus 2t is equal to 0. So we have y plus s minus 2t is equal to 0. So from there now, you need to get, or rather correct like terms, or find the value of x first and then find the value of y. So you can make from the two equations, you can make x the subject, also you can make y the subject. So by doing so, we are going to have x is equal to when we take this one the other side, when you take this one the other side, it's going to be a negative. This one is going to be a positive. So you are going to have minus 2s plus t. And then when you make y the subject here, you shall have y is equal to, you take these the other side, you're going to have negative s plus 2t. So what does this mean? This means that the value of x is known, the value of y also is known. So what do you do for you to get the missing values of s and the t? So you need to let them as free variables. So what is a free variable? A free variable is simply any number that exists in a real number system. So meaning that since you've already found the value of x and the value of y, you can let s and t to be any number in the real number system. So by doing so, you are going to say that let s and t be real numbers, or be free variables, if you may like. So be free variables. So let them be free variables. So if they are free variables, meaning that they can be anything in the real number system, and therefore we are going to let them as s, we can let s to be a and t to be b. So if s is a and t to be b, then you come back and replace them here, because you know that x is equal to negative 2s plus t, and now you've said that s is a and t is b, meaning that you go and replace them. Instead of you maintaining them as s and t, replace them now as a and b, like that. So we are going to say that therefore our x is equal to negative. Okay, so we are going to say therefore our x is equal to negative 2. Where there is s, now we are putting what? A. So we have 2a plus, where there is t, we are putting what? B. So we put a b there. And then we have another one. Another equation is y is equal to, where there is s, we are putting negative a plus 2t, we are putting a b there. So 2b, like that. All right, now in this case, remember we have x is equal to that, y is equal to that. What is our s? Our s is a, so you can even write that s is a. And what is your t? Your t is b there. So your t is a b. So this means that you've done what? You've created these equations. Now you need to get the exact values, because the question is find the kernel. So after you get the values of x, y, s, and t, now you need to factor out and get the specific values of a, b, x, y, s, and t. So you need to get their specific values. How to get their specific values? Start by factoring them out. Okay, so in this case, remember here what we've obtained here is a and b, which is appearing in all the equations. So what we are going to do is that we are going to factor out the a and b. So if we say, if you have to factor out the a here on these equations here, if you have to factor out a here, you are going to have a is common. If you factor out a, you're going to have a common, open. If you factor out a here, you remain with negative 2. Factor out a here, you remain with negative 1. Factor out a here is 1. Factor out a here is a 0, because don't have a, so it's a 0. Then you say plus. You come here on the other one, again the same thing. You factored out, now you go to factoring out b. So factoring out b, you remain with a 1, because this is a 0. Here you remain with a 1. Then when you come here factoring out b, here it's a 0, you remain with a 2 there, so you write a 2. So you write a 2. Then you come here, when you factor out a b here, it's a 0, because don't have a b, so you write a 0. Factoring out a b here, it's a 1, so you write a 1, like that. So remember, you need to put that b as outside. So you factored out a throughout, you've gotten this. You factored out b throughout, you've gotten that. And now the question is find the kernel. So what do you do for you to get the kernel? So for you to get the kernel, so in this case, our kernel is simply the two vectors that we found. So our kernel is, so the kernel, for you to get the kernel, just say that the kernel is these two these two vectors you found, which are negative 2, 1, 1, 0 and 1, 2, 0, 1. So the kernel is simply those answers that you found, putting them in vector format, then they become kernels. So that's how you get the kernel, like that. Then there are cases where they ask you to get the basis of the kernel. So if you are told to get the basis of the kernel, what you simply need to do is to put these the kernel that you found in a set format. Okay, to put these kernel in a set format. So if you are to just open the curly bracket and then you put this, okay, you put your kernel in a set form like this. You've seen what I've done. I've used these curly brackets here, these ones here, to put my kernel in a set format. So once you do that, then you've gotten what we call as the basis of the kernel. Then they can also ask you to get the dimension of the kernel. So to get the dimension of the kernel is just to count how many bases do you have. So in this case, we have how many bases we have. I mean, how many of the bases do you have in the kernel? You have 1, 2. So you have 2 of these vectors, and then the number of those vectors in the basis is what we call as the what? The dimension of the kernel. So in this case, we only have 2 of the vectors in the basis. So that becomes our dimension of the kernel. So this is how we simply get the kernel of a linear transformation, the basis, and the dimension of the kernel. So for today, let's end here. See you next time. But please don't forget to follow my Facebook page, invite more people so that more people can be able to find my videos. And also don't forget to go and subscribe to my YouTube channel for more tutorials. See you next time.